Okay, so this is example 4, another one with friction. I've put an extra question here that is currently not in the booklet, but by the time you watch this video, some people, this may well be in the booklet. One thing I'm going to change is they talk about a force F newtons. I'm going to change that to X newtons, just because there can be confusion with friction being F or FR. Right, so we've got a box on a horizontal surface, ish. So this is a rough surface, that means we're going to have friction. I'll just show the kind of that bit, and I've got a mu, a coefficient of friction of 0.3, 20 kilograms, and I've obviously got a number of forces on this question. So because it's rough, I'm going to have friction, so let's get the force on first. So a force of magnitude we call an X is applied to the box at an angle of 24 degrees above the horizontal. X and 24 degrees. Let's go right and up. We're in contact with a surface, so we've got a reaction force. It's a rough surface and we're in contact, so we've got a reaction, a friction going against that, and we've also got the 20G. The one thing I also need is these two lengths. So in terms of your SOHCAHTOA, we are adjacent to the angle here, so adjacent is SOHCAHTOA, so this is going to be X cos 24, making this opposite, and then X sine 24. So, first of all, it says the box is on the point of moving. So let's have a look at what's going on. So we can look at, first of all, the vertical forces. Again, I'm going to do this in F equals ma. Because the object's not going to be accelerating in this direction, or in fact all that direction, you could do forces up equal forces down. So I've got R plus the X sine of 24, which is pulling up, and reducing the contact force, because reducing the amount of kind of contact that it feels. Take away 20G, that's going downwards. Because it's in equilibrium, that's equal to 20 times 0, or just 0, i.e. A0. So you could, if you wanted to, as I said, go straight to forces up equal forces down in that case. I'm then going to look horizontally. I'm going to always do this as an F equals ma, because again, it's likely to be accelerating these kind of questions, like the question I put in part C here. So I've got X cos 24, take away friction, equals to 20 times 0. Maybe again just emphasizing that even though there isn't motion here, it's really important to get that. I could have put 20 times 0 here as well, but this one will generally always be 0. This one sometimes is not, like in part C. And then the last thing we haven't done is looked at the friction, so we'll just say that friction is equal to mu r. You know mu is 0.3, so 0.3 r. And then it's just a case of putting these kind of equations together. So top one here, you've got, I'll change the order actually, I'll say X sine of 24 plus R, and I'm going to say that's equal to 0. So I'll take this onto the side, so that's equal to 20G. Explain maybe why I do that in a minute. The next one, I've got the X's first, that's why I had it for the top equation, so I've got X cos 24 minus, so minus friction is 0.3R, so minus 0.3R equals to, that's just 0. So I've got these two equations, I've got two unknowns, I've got X, and I've got R. Let's do 1R there, minus 0.3R here. So what I'm going to do is I'm going to put this in my graphical calculator, I'm going to put it into the simultaneous equation mode. I haven't got the emulator working, I don't think. No, my emulator's not working, so I'm going to go into, I'll just explain, so into my graphical calculator, or you can do the same in the ClassWiz calculator, into the equation mode, into where it says simultaneous, make sure I'm in degrees, unknowns 2, and then my coefficient. So you'll see at the top, if you're in that mode, it says ANX plus BNY equals CN. So a number of one variable plus a number of another variable equals to a constant. So the first thing I'm going to type in is how many X I've got. Well, I've got sine 24. Obviously, normally the coefficient written in front, but just how we've written them from the mechanics. So that's about 0.4. I've got 1R, so I've got 1, and then I've got 20G, so 20 times 9.8, that's 196. On the bottom line, I've got x cos 24, so my next one is cos 24, about 0.9. I've got minus 0.3, that's the next thing, and I've got 0 at the end. And my answers come out in the order of the variable I put in, x first, then r. So the first one it says is 56.8. The next one is 170. What's going to round to 173, and that's r. I could solve these by hand, but you need some sort of calculator to be able to do like statistics and stuff that we do in the course. So, even if you're not good at the moment, you'll need that for your mechanics and your pure, because you'll need that for the statistics. So you could solve these by hand. You could, for example, make this top equation r equals, sub it into the bottom one. You could make both of them have the same number of r and eliminate. There's lots of options, but I'm just using a calculator for now. Right, the part B is to find the magnitude of the contact force. So the contact force is anything that's a contact force of these two. A friction is only a force you get if you're in contact with a surface. Reaction is only something you get if you're in contact with a surface. So that bit there is, I'll do part B up here maybe. Part B then. And again, I think there's a bit in the chapter that mentions this. Possibly I've taken this out of the booklet. So it's the Pythagoras effectively the R and the friction force. Okay, so I've got the magnitude of R, which we know is 173, although if you've 172.9 really, plus friction. Friction is 0.3 R, so that's squared. That's 0.3 times 173 squared. If you put that in your calculator, again, if you use the 172.9, you get a slightly more accurate answer. So that's what I'm actually going to do, I think. 0.3 times 172.9 brackets squared. I've got something that rounds to 181 newtons. What do we get for 173? Something that rounds to 181. It's slightly different, but they're very, very close. So that's what you get for that value. Okay, so magnitude of contact force, the Pythagoras of the reaction and the friction. Right, I'm going to get rid now in a minute of these to do part C. So you can always go back and look at these if you want to. So what's actually changing in part C? Get rid of these two equations, don't need them anymore. And this is what I want to emphasize about using your F equals MA and how adaptable it can be. So I'll now do part C. So this X has now changed to 70. So if we look at the vertical, the only thing that's really changed, we've got R plus, but it's just going to be 70 sine of 24 now, minus 20G. It's still in equilibrium vertically, that's not changed even though it's moving across the surface, so it's still equal to 0. This is for our vertical F equals MA, but with A is 0. Not changed other than the extra 70. Horizontally, again F equals MA, but it's in motion, so this time the A is not equal to 0. So here, the only thing that's going to change, we're going to have 70 cos of 24 minus friction. The friction value that we didn't quite get to is still going to be 0.3 R. The R will have changed, but we didn't really calculate it properly last time. Oh, I guess we did in the end. So that's equal to 20 times, so this time it's just 28 because we're looking for that acceleration. Okay, so 70 cos 24 minus 0.3 R equals 28. Use this space maybe now a little bit over here. Same as before with just some very minor tweaks. That's the kind of good thing about doing it, setting up as F equals MA. So this top equation here, I'm going to rearrange to make R equals. So R is going to equal to 20G minus 70 sine of 24. So I'll put that in my calculator. It's 167.5. It's not a final answer, so I won't round it quite as much as I would do. And then I'm just going to sub that into here. So I'm going to have 70 cos 24 minus 0.3 and 167. I'm probably not going to use the 167.5. I'll just use the answer button in my calculator. Equals to 20a. You could, if you want to, write down what you get for that left hand side. Oops, 70 cos. So I pressed the wrong button now, so I'm going to have to use the 167.5 now. So 70 cos 24 minus 0.3 times 167.5. That gives me 13.698 equals 28. I probably wouldn't normally write that down. I'd probably just type that in my calculator, then divide by 20, and I get 0.685 meters per second squared. So if you get in the habit of using your F equals ma, and particularly in the line of where your motion is going to act, if there's acceleration, you're going to set yourself up a lot easier than being like just forces left equal forces right when there can be motion. Okay, up equals down again, if you're not going to come off that surface, which you won't in pretty much all our questions other than a lift where the surface moves with you, you kind of set yourself up properly there. In the second question, what you might notice is I didn't use the simultaneous equations. That's because I only had one unknown in this top equation, so I didn't really need to. I could have set it up with like 0a, so like r plus 0a, and then done this number of a, but I only had one unknown, so I could quite easily solve that and sub it in. Whereas before, because I had the r and the force on here, we had two unknowns, so just a slight difference there. Easier a little bit really to solve with less unknowns. Okay, so that extra part C that hopefully might be in the booklet soon.